Welcome to the explainer. So you click a link, and then you just sit there, waiting for the page to actually load. We've literally all been there, right? It's this super frustrating, everyday problem we've all just kind of accepted as a fact of digital life. But what you might not know is that behind the scenes, there is a massive, totally unseen battle being waged right now to fix this bloated internet. Today, we're diving into the heavyweights of image compression to see exactly how the modern web is being completely rebuilt from the ground up. Let's get into it.
To really wrap our heads around the scale of this problem, I want you to take a quick guess. What do you think is the heaviest, most invisible anchor weighing down the modern web today? Like, what single element is eating up the lion's share of data every single time you load a site on your phone or your laptop?
Well, if you guessed images, you hit the nail on the head. Images consume over 50% of all average website bandwidth. Seriously, just think about that for a second. More than half of all the data flowing across the internet just to render a web page is literally just trying to show you pictures. It's a massive amount of bloat. And honestly, it's exactly why a total revolution in image formats is so desperately needed right now.
So here is our roadmap for today. 1. The image bloat problem. 2. Meet the AVIF format. 3. Crushing the competition. 4. The AVIF Achilles heel. And 5. Real-world AVIF action.
Section 1. The image bloat problem. The invisible anchor weighing down the web. Okay, so to really appreciate the solution here, we've got to respect the problem. The current standard of the web is frankly incredibly old, and it's holding back the modern internet in ways you might not even realize. Obviously, the undisputed king of the internet for decades has been the JPEG. But here's the catch. JPEG is over 30 years old. Now, it's done remarkably well for its age, for sure. But when you actually force a JPEG to compress into a really small file size, it becomes incredibly blocky and pixelated. Then, we have WebP, which was supposed to be this big upgrade, but WebP is now over 10 years old itself. It's limited to an 8-bit color depth, and it uses this thing called chroma subsampling at its best compression levels. In plain English, that basically means the edges of highly saturated colors get severely smudged. So, by relying on these legacy formats, we're basically forced to either suffer from really poor visual quality, or we use massive file sizes that just result in slower sites and absolutely astronomical cloud hosting costs for developers.
Section 2. Meet the AVIF format. Enter the next-gen challenger.
All right, meet AVIF, which stands for the AV1 Image File Format. It's a modern, completely open-source image format that was designed from the ground up to solve these exact problems. But here is the really fascinating twist. AVIF isn't actually a traditional photo file. It's based on the AV1 video codec developed by the Alliance for Open Media, or AO Media. So essentially, an AVIF image is just acting as a single, highly compressed frame of a next-generation video. It's literally borrowing cutting-edge video technology just to make our still pictures smaller and better. How cool is that?
And the timeline of how fast this all came together is just staggering. Back in 2015, AO Media was founded by this coalition of absolute tech heavyweights. We're talking companies like Google, Mozilla, Netflix, and Amazon. They basically wanted a royalty-free alternative to formats that were completely bogged down by patent fees. So by 2018, they released the AV1 video codec. Just a year later, in 2019, the very first AVIF specification for still images was published. And by July 2020, boom, it achieved official ISO standardization. I mean, this was not your typical slow tech evolution. This was a highly targeted, rapid deployment by the biggest names in the industry.
Now, what's really fascinating here is exactly how AVIF pulls this off. It uses this amazing secret weapon called chroma from Luma. Usually, older image formats store brightness completely separately from color. But AVIF, it uses the brightness channel to actually guess what the color channel might look like. And because brightness and color are usually pretty correlated in an image, a good guess means the file simply doesn't have to save as much data. The end result, stunning visual fidelity, incredibly sharp edges, and all of it at a fraction of the file size.
Section 3. Crushing the competition. The tale of the tape.
So Cloudflare actually ran this super fascinating test where they forced JPEG, WebP, and AVIF to compress an image down to a tiny 17 kilobyte file size. And you guys, the results are literally night and day. At 17 KB, the JPEG suffers from really heavy color banding and just a total loss of fine detail. It looks rough. The WebP image is terribly smudged and pixelated. Honestly, it looks like someone just smeared Vaseline all over the lens. But the AVIF, it maintains high fidelity, sharp edges, and clear text. When it's forced into a corner with ultra-low bandwidth, AVIF completely destroys the legacy competition.
But to be fair, it's not the only new format on the block right now. There's also JPEG XL. An extensive testing by the YouTube channel 2 Clicks Philip revealed some really objective, interesting nuances between the two. When you absolutely need ultra-low file sizes, AVIF is the undisputed winner. It miraculously preserves sharp detail and even film grain in situations where JPEG XL just turns into a blurry mess. However, looking at it objectively, JPEG XL does win when it comes to massive, lossless, high-quality images. Plus, JPEG XL has this thing called progressive decoding, which means a low-resolution placeholder loads immediately while the rest of the image downloads in the background. AVIF actually cannot do that.
Which brings us to Section 4, the AVIF Achilles heel. No tech is perfect.
Yeah, if we really want to truly understand this technology, we have to look at its weaknesses, right? So here is a rapid-fire look at AVIF's drawbacks. First up, slower encoding speeds. Because AVIF uses these highly advanced video compression algorithms, it requires significantly more CPU power and time to actually create the file in the first place. Second, as we literally just mentioned, that lack of progressive rendering. An AVIF image will not show a blurry placeholder. It shows absolutely nothing on the screen until the entire file is fully downloaded. Third, legacy browser support is definitely an issue. If you have users still hanging on to Internet Explorer, well, they won't be able to see AVIFs at all. And finally, there's a lack of native support in some major image editors, like Adobe Photoshop, for example, meaning creators often have to jump through hoops with third-party plugins just to even work with the files.
Section 5. Real-world AVIF action. The champions using it today.
But hey, despite those hurdles, the industry is charging forward. Let's look at the tangible outcomes here and see how titans of the web are already going all in. Netflix is actually utilizing AVIF right now to compress images down to an incredibly tiny 0.08 megabytes. This is saving them massive amounts of bandwidth across their entire global UI, while still retaining totally pristine quality. Meanwhile, Cloudflare has built a pure Rust Ravenni encoder right into their image resizing tool to rapidly generate AVIFs at the edge of the network. And platforms like Cloudinary, they're offering this automated F-auto feature, which brilliantly detects if a user's browser supports AVIF. If it does, it serves the AVIF automatically, and if not, it gracefully falls back to a JPEG for older browsers. It completely automates the whole optimization process.
But here's the kicker. It isn't just for web design anymore. This format is bleeding over into physical hardware. Access Communications is actually bringing AVIF support directly to their edge-based security cameras in Axis OS 12.11. For devices running their RTPG9 processors, they're using AVIF for security snapshots. What does that mean? It means way smaller file sizes on their servers, but significantly better preservation of those super fine forensic details when they actually need to go back and review security footage. Getting better clarity without jacking up storage costs is just a massive win for the physical security sector.
And honestly, this brilliantly illustrates the real driving force behind this entire revolution. As noted by Cloudflare, the old licensing model has become unsustainable. This has created a huge incentive for web giants to get behind the royalty-free alternative. AVIF isn't just about getting faster load times or sharper edges on a screen. It's really about breaking free from the patent-encumbered tech of the past. As we've seen today, we are quite literally looking at the blueprint for a faster, completely open-source internet. So I'll leave you with this. If the biggest tech giants in the world can band together to kill the standard JPEG, what other legacy, patent-heavy technologies are next on the chopping block? Thanks so much for joining me on this explainer, and keep questioning the technology behind your screens.